This is for MA 098, and we're talking about the subject of simplifying roots. So when we have a square root and we have a number underneath the square root, how can we simplify that? That's the question. Well, for some numbers, it's quite easy to do. So for a number like 100, you just have to think, well, 100 is the same as 10 times 10 underneath the square root. And 10 times 10 underneath the square root is the same thing as 10 squared. And when we have 10 squared, we want to think of this 2 and the exponent and the root of 2. There's really a 2 there, but we just don't write it. Those simplify, and so that simplifies to 10. And another way to look at this is to say, well, if I have 10 times 10, that's exactly 100. And when I take the square root of both, because there are two of them together, this 10 times 10, that simplifies to 100. So then both of those would simplify to just 10. Let's look at a different example. How about 16? So 16, when I take its square root, is equal to 4 times 4 when I take its square root, and that's equal to just 4. Because one way I can think about it again is 16 is the same as 4 times 4. So when I take the square root of 16, that's the same as the square root of 4 times 4. And since there's two of them multiplied together with the square root, then that's equal to 4. One last example for these types. If I have 25, 25 is the same as 5 times 5. And if I take the square root of both, there is, again, two of them. And so with the square root, two numbers the same multiplied to each other, then that simplifies to 5. Okay, that's a little reminder of what we're doing, but that helps us remember what it is we want to think about when we're doing other numbers. Let's say 26. So let's do 28 instead. So the number 28, when I take its square root, there is not two whole numbers that I can multiply together. So a times a, that equals 28. There's no whole numbers, a times a, that when I multiply them together equal 28. So what I have to do is do 28, and then I have to think of something that's close. So I know that 28 divided by 4 is 7. So 4 times 7 equals 28. Now notice these are not two whole numbers, right? Multiplied together. That equal 28. But they are two whole numbers multiplied together. And then 4, this number 4, is 2 times 2, and then times 7. So this is 4, this is 4, this is 7, this is 7. So that is equal to 2 times the square root of 7. And these two together, multiplied with the square root, simplified to just 2. But the square root of 7 is still there. Let's do another one. How about 126? So 126, take the square root. Well, 126 is the same as 2 times 63. And you take the square root. And 63 is the same as 9 times 7. So I have 2 times 9 times 7. So 2 times 63 is 126. 2 times 9 times 7 is 2 times 63, which is the same as 2 times 9 times 7. It's the same as 126. I took the square root, took the square root, took the square root. So one more time I can simplify by saying this is 2 times 3 times 3 times 7, all underneath the square root. And there are two of them multiplied together of the same number. So I can write this then as the square root of 2 times 3 times the square root of 7. Now, one thing I want to make sure that we notice here is that I did not put a square root on top of the 3. I clearly broke it off from each number. Well, traditionally, when we have that situation, we write the 1 without the square root out front. It's not required to do that, but that's what we traditionally do. And then 2, and then 7 underneath the square root. And there's nothing wrong with that number. That number is perfectly fine. But what we do to make it look nice is write 2 times 7 underneath the square root with a 3. And then we could multiply that back together and write it like that. 3 times the square root of 14. Okay, now the last one that I want to look at is 128. So the square root of 128. Well, 128 divided by 4 is 32. So that's the first thing I'm going to do, is write 4 times 32. So the reason I chose 4 is because I know that the square root of 4 is 2. So I just divided 128 by 4 first. So let me make a little note over here. I took 128, divided it by 4. That's equal to 32. And I did that so I could start thinking about how I can break it up. Now, can I break up 32 again? So 32 divided by 4 is equal to 8. So 4 times 4 times 8 underneath the square root. So I have 4, that's this 4, and then 32 is the same as 4 times 8. And then I can break it up one more time. I have 4 times 4 times 4 times 2. So this is 4 times 4 times 4 times 2 makes 8. And all of that is underneath the square root. Well, I have these first two together multiplied. So I'm going to make that a 4 underneath the square root with 4 times 2. So remember, I have these two together underneath the square root. So that just becomes 4. And I'm left with 4 times 2 underneath the square root. But then I could write 4 times the square root of 2 times 2 times 2, because remember that 4 is the same as 2 times 2, and I could do that one more time then and have 4 times 2 times the root of 2. So this is this 4 still recopied, and then 2 times 2 put together underneath the square root. So I just made that a 2, and then I'm left with this square root of 2. And then 2 times 4 makes 8, so I could write this as 8 square root of 2. So the root of 128 is the same as 8 root of 2. So I also want to show the same exact problem in one different way. 128, take the square root. I could have written that as 64 times 2, because 64 times 2 is 128. And then said, oh, well, 64 is 8 times 8 times 2. Take the square root. So then when I have 8 times 8 underneath the square root, then that's equal to 8 times the square root of 2. And you notice the second way was just faster, and I got the same exact answer.